Well, hi everybody, and welcome for the start of video number 2 on the Philips 922 AM shortwave radio. No FM in this one. And the last video ended with me jumpering out the on-off switch because the on-off switch was misbehaving, only to find out the on-off switch is not misbehaving. Something else is causing the variation in the current draw on the power cord when I plug it in. So I went away last night thinking, going to be a blown power transformer here, but I realized there is no power transformer. This is a 5-tube radio designed specifically without the power, without the need for a power transformer. So I thought a little more, what could the mechanical connections be that might lead to this variation in the power draw? And the answer is the tubes. So I'm guessing I've got nothing more here than a bad tube contact on one of the heaters, and that's interrupting the whole heater current in the whole heater string on the 5 tubes, and the result is I get this weird looking shaky current draw on the power line. So that shouldn't be too hard to figure out. The other thing is, even though the power draw is kind of shaky, it's not like a short circuit is taking place. It's the opposite. It's an open circuit. So I think it's really rather harmless to operate the set in this condition. Observe the meter here where the shakiness shows up, and poke around with the tubes and maybe discover it is a tube and which one it is. So that's what we're going to attempt here now. It's kind of a large chassis for such a small radio, isn't it? But it is a multi-band radio. So it looks like the speaker's still connected. Okay. And quick little safety check, everything's fine. Let's plug this guy in. Now the meter to watch is this one. And normally I would expect a radio like this to, because I have the light bulb in the circuit over here, current limiting light bulb, my expectation would be on warm-up this meter might run around 100 volts. Full warm-up might go a little higher, maybe a little lower. That's what I would expect. I expect this meter to be hanging right around 100 volts, which is right on the bottom of the scale, because this meter starts not at 0, it starts at 100. Excuse me, it's kind of a curious thing, isn't it? Meters that don't start at 0. So let's turn the power on here. There it goes. Oh, look at that, it's behaving completely normal. Oh, that's not so normal. So what we saw, let's watch that meter. Okay, so there's the effect. Looks to me like it's a heater going open. Let's wiggle some tubes here. Looks. Last tube to wiggle. Well, excuse me, it seems to be drawing current. Now, it's about 115 on there, and there's actually 124 volts available, 123. So some of the supply current is causing a voltage drop on the light bulb, and you're seeing the remaining 115. It's not very much power. The tube's lit up. The shakiness is gone. Let's see if we can hear anything. I don't hear a thing coming out of the speaker. Speaker sounds entirely dead. Entirely dead. Now, can we see that all these tubes are lit? They should be. If one is lit, they should all be lit. Yeah, I can see the heater in every tube. All 5 of them. Tubes are hot now. Do I have this on phono by some chance? Maybe it's switched to phono and excuse me. Should have cleared my throat before I started. Okay, I'm changing the band switch and you'd expect to hear some clicking and popping. There's nothing coming out of the speaker. So why would that be? Bad speaker connection. No, there's nothing bad about the speaker connection. Volume is up full, so if things start working, we're going to be jumping here. And we don't seem to be getting anywhere at all. Yeah, that makes me suspicious about the B plus not being there. Now, absolutely nothing. Let's tip it up. Remember, the volume control is up full, so. And this is very precarious how I have the radio here. I don't like it. It's sitting on top of my carpeted surface. It's really kind of wobbly, very wobbly. So, bearing in mind it may fall in my lap at any minute, let's continue. Let's see if we can find some B plus in here. So what I do is just take my voltmeter. Where can I put it here? By the way, the supply voltage is jumping right up. So whatever's happening is happening right now. I can see it there. You see that meter jumping? That's going to end up being a bad tube heater or something like that. Jeepers, look at it go. If it's a tube heater or something like that, they're all going on and off together, and it's pretty hard to sort out which one of them is causing that. Let's keep going on the B plus because yeah, probably won't find B plus on a radio that can't maintain voltage here. I'd have to read the voltage across the heaters. There's a little B plus there. Read the voltage across the heaters and then see which one has the jumpy voltage. Let's try that. So we'll switch to 20 volts AC because the heaters are heated with AC power, and we'll just try to okay, so here's whoa, radio. What did I tell you? I don't like this at all. I'm gonna drop it if I keep this up here. I know I'm gonna do that. Oh, that's good. There we go. Okay, now it's very unlikely to fall over backwards. It can still fall over towards me though. So, voltage still jumping. Keep jumping, man. I need you jumping now. Voltage across this heater. more than 20 volts on the heater? Yeah, because that's the 50C5 or something like that. So the question is, does it get the full 120 volts? That's what we're looking for. There's the 50. The radio's gone steady. Come on. Well, the radio's no longer jumping up and down, so my opportunity to find this problem is gone. Phooey. Still no sound whatsoever. So, okay, so now it's steady. Let's check the B+. I can tell from this voltage it should be producing around 120 volts or something like that. Oh. Let me get it on the right scale here. And you can hear that coming out of the speaker. That no B+. There you can hear sound out of the... That's probably the grid there, running at minus... I thought I saw minus 27. Minus 3, 2, 1. Look at it dropping. What's going on there? Let's let it... My meter was drawing a charge off that. So here we go again. I don't know what to make of that. That's curious. Show me 100 volts here, somebody, anybody. Oh, there's something. Look at it go down. From my meter? Try that again. Here we go. 40. Just dropped right down when I put the meter on it. And another one, same effect. Boy, that's got me wondering. Let's look at that again. Okay, so if I go on this, what I think is the grid, 20 volts dropping fast. And if I give it a moment to build the charge up again, and I go on, let's say here, 86, 85, 40, 30, 20, my meter, it's a high impedance meter for crying out loud, isn't it? Doesn't actually say on it, but for crying out loud, it must be a high impedance input. I can't imagine it's anything other than that. Okay, that's two mysteries. What was the jumpiness, which is gone now, and what's going on with the B+ on this thing? Yeah, that's almost as if the B+ is getting to where it's going through a fairly large resistor, but the normal current draw is very low. So after a little bit of charge passes through the resistor, the other side of the circuit, or the bulk of the circuit, is charged up. And I come along, stick this meter on it, and begin drawing down the charge. on the far side of this large resistor, high value resistor. That's an interesting story. I don't know what it has to do with reality here. Oh, it's always good to have a theory, even if the theory is wrong. You're better off with a wrong theory than just blindly going forward. So we take a look at the power supply here. Where? Here's the power supply. Oh, there's nothing spectacular about it. Here's the capacitor. I wonder if the capacitor's bad. The rectifier could be bad, although I tested it good. There's the 33 ohm resistor. Excuse me. Seems like I'm getting another cold. I had my flu shot. Here in Canada, everybody gets a flu shot for free. And the government strongly encourages us. And we don't even have to go to the doctor. You can actually go to a pharmacy. The larger pharmacies offer the shot. They'll actually give you the shot right in the pharmacy. So, because the flu is taking off in Canada a little bit. You know, the flu is one of those diseases nobody pays attention to. It's really funny. You'd be all frightened about something. Every year the flu kills in Canada 3,500 people. I think it's 35,000 in the States. 35,000 people. And we sort of laugh at it. We laugh at the flu like it's some kind of joke. It's strange behavior, but then again, we're people. We don't think so straight. But anyway, I always try to get the flu shot. And even though, you know what, it's not so effective as they say, often it's not going to prevent the flu, but it may reduce the strength of the flu, which is good. I haven't had the flu. I think I've had it once in my life. I think that's only once. A long time ago. So, that's the situation with the flu here in Canada. Now, of course, I got sniffles and that. This isn't the flu. I got some kind of rhinovirus or something else like that. Now, I'm waiting for the radio to start that shakiness again, but it hasn't. So, whatever it was that was acting up has decided to, it's happy now. And, well, let's take a look at the 33 ohm resistor. Look at voltages around it. Did that already, but let's do it again. This time I've got the schematic in front of me, so it may make a little more sense to me. The -5 to the chassis. Maybe the part of the problem is I'm reading to the chassis, and the other side is -3. Yeah, there's something badly wrong here. You certainly shouldn't see voltages like that. Tubes are all lit up and look pretty normal. You know, I'm tempted to say, well, the rectifier tube must be bad, but I did test it. Let's see if I'm really testing the right terminals. I must be. So 0.027 capacitor. What's that doing there? Probably suppressing oscillations or something like that. So pin 7 should be showing 120. This is right there, 120 volts. Oh, here's the actual readings you expect right on the capacitors. 150, 150. right on the capacitor. And where are you, Mr. Capacitor? Right there. So let's look at that. Sorry if I'm putting my arm up in front of that radio. You know what? I can in front of the meter. I can put this here now, because the radio's not going to fall over. Okay. Show me some B+. Wow, 1 volt. Yeah, there's something. Look at it go. Look at it go away. What is going on there? And this one. There it goes away again. The thing I'm surprised is if my meter is draining off that voltage or that charge that's supporting that voltage, for crying out loud, there are just parts in the radio draining off more current than my meter would ever drain off. So how does it ever get there in the first place? And it's all through the radio. Let's take a look at the, let's see, the plate is pin, oh, I can't read that. I must be allergic to this radio. Excuse me again. That looks like an 8. I don't know what that is. These all have the same pin out, these tubes, if I remember right. So let's pick on one. 12B E 12B E 12BA6 5 on the 12BA6 and the 12BE6 5 is the plate. Yeah, I think they're the same on these tubes. Should memorize that, shouldn't I? 5 is the plate. So without knowing for sure what tube I'm testing, pick pin 5. 1, 2, 3, 4. Yeah, that's a good sign. Turn on my sleepy meter. That would be a grid, probably. There's no B plus making it here. Can't really say that, because there's the B plus draining off the capacitor again. A very curious behavior. Let's read that voltage with my BTVM and see what we got. The VTVM, vacuum tube voltmeter, by the way. It's a bit of an old term, isn't it? Kind of whipped it out there without much thought. So we're on this meter now. Let me swing you out here just a little bit more. Put you on the edge of things. Maybe if I move this back just a little bit. Okay, so you're watching this meter now. I'm on the 150 volt scale, so it's 150 volts full scale. So we'll go right after some of the same voltages, either side of the 33. It's indicating there's an AC voltage there, the way it's behaving. I've got it set to DC. And see, it does this funny pulsing thing. You get the same thing there, as if there's an AC voltage there. put my meter on AC and let's see. Oh. And maybe that rectifier is actually shot. Well, we really got to change the rectifier. Even though it tested good, I tested it on what's called an emissions tester. It's not much of a tube tester, that type of tester. It is just a rectifier, so you'd think it would be a valid test. Let me kill the power to the radio so I don't get a shock. And I better scare up another, I think it's a 35W4. I gotta scare one up in here somewhere. Let's see if I can find one. There's my drawer of long tubes. Maybe this guy here, he looks like he might be one. $50. That's a 50. Not the right kind, not the right kind. This guy, 35W4, right there. I think here's another one. 35W4. There's two of them there. Now, just because I have them in my collection doesn't mean they're good. But let's see. We'll pull out this one, and we don't want to mix these up. So this one I will put over here. There it is, over there. And we'll stick in this guy. Now, if this somehow works differently, and maybe we're going to get B+ into parts of the radio we haven't had it in before, or for a while, and maybe that's going to cause an effect, an unexpected effect. So, once again, we'll put it on with current limiting, and here we go. Jump into action right away here. Steady voltage behavior here. Still on AC, but back to DC 150 full scale. No difference, no difference. Oh, look at that! See the voltage go down? The radio's making some sound. It's making sound like a radio. Here, let me just put you by the... So it's making some sound now. But that's just adding to the mystery. What about an improperly wired radio? What if this isn't wired right? Well, you know, that is the AC line coming right in there. I better find a better ground point for testing against. It looks like it might be right there. Same effect. Something pretty mysterious about this. It's a mystery. It's a mysterious. It's a mystery. Well, let's look at the circuit diagram, see if we can get into something. Well, I could start disconnecting wires into the radio and begin isolating the power supply from the rest of the radio. That's not a bad idea. There's quite a number of wires to do that with. Now, there's a short circuit on one section, pulling the voltage down everywhere. This doesn't add up with all the things we've seen so far, but then, nothing's adding up, so... Wow, did you see that jump up? The whole voltage was there. And that one's going negative. The whole voltage is there, look at that. And what this is telling me is the high voltage is going into circuits that are much higher impedance than even my 2 voltmeters, including my vacuum tube voltmeter. I'm a little bit stumped here. I'm stumped in the sense that anytime I try to measure the B+, it goes away. Yet it's there to be measured. How can this possibly be? Okay, let's go look for this big B+ briefly on some tube pins. So, wow, those tubes are buried up in there. Let's go up in here. See what we find. So, we assume 1, 2, 3, 4. This might be plate. There it is. There it goes. There it is, and there it goes. Whoop. There it is, and there it goes. So anytime I try to read it anywhere, it draws it down. Now, to have such a high impedance, man, all these capacitors have to be in excellent shape. This really isn't making a lot of sense. So I think what I'm going to do is I'm going to post this video and see if some wise people out there happen to have a hint about what this might be, because I just run over it once again really clearly. The radio's not working. There is some sound coming out of the speaker. Suggests the B+ must be there for the speaker to make some sound. When I measure the B+ with high impedance instruments, the B+ appears to be drained away. Looks like the B+ is reaching up around 110 volts, 100 volts, somewhere in that range. As I draw it away by having my meters connected, the radio's operation does not change. And I hadn't mentioned this while I was doing it, but I was listening for the speaker to fade out. It never faded out. There's kind of compounding the mystery of what's going on here. We changed the rectifier tube, made no difference. And then we have that jerkiness that we saw earlier on. It seems to have gone away now. Probably a completely unrelated problem. But who's to say for sure? So there's the mystery. The mysteries abound. Mysteries continue. But I like mysteries. I like it. So that's it for now. If you have any idea of what you think I should do next, try next, a test or a component or anything at all, or even a shot in the dark, you know what I've learned in life is that the stupid, crazy, bad ideas are very helpful because they lead to the good ideas. So anything that comes across your mind that it could be, I'd be interested. interested in thinking about it. Thanks a lot for watching, and hopefully next video I'll be nailing down what's going on with this radio. Hopefully.